notes. Continuous compounding. So the last thing that we looked at was that the effect of compounding more and more and more and more often still improved how much you were making, just less and less and less and less. So then there is this idea of continuous compounding. So I want you to think about this when you're taking the test. The first thing you're going to look for is, does it say simple interest or not have the word compounding? If it doesn't, you're using that simple interest formula, this or this. If you see the word compounding and then something that tells you how often it's being compounded aside from the word continuous, so quarterly, monthly, something like that, annually, we're using the compound interest formula, which is P times 1 plus R over M to the M times T. You will get a formula sheet, but I won't tell you which one to use where. And I can't remember if the formula sheet has this one or this one for simple interest, but if it has this one, all right, I'll give you that one to add to it. And then the third thing that might be on there is continuous compound. And that's another formula. It is P times the number E to the R times T. Just the E is to the RT. That's not in parentheses, PE to the RT. Just the E is to the RT. So this is the formula that we're going to use today. So this one, simple. We're just looking for the word with an interest problem without the word compounded. So we use when no compound. This one is our compound interest. So this one we use when we see the word compound. And we don't see the word continuous. This one we're going to use when we see compound and continuous. Now, I want you to notice that there are exponents that are variables. And there is the number E. So when we're solving for one of these exponents, what button on the calculator are we going to have to use? The natural log, the inverse of our E function. So we're kind of going back to something that we did in the last chapter, right? We had to do it when we solved for T up here. We would have to use the log of whatever base we have. All right, so let's look at that last problem that we just did where we had simple interest compounded semi-annually. We went all the way to compounding it every minute. And let's look at what that principal that was $400, a rate of 6% interest in a time that is 8 years will give us if we compound it continuously. Remember, if we did it every minute, we came up with, the last one that we came up with was $646.42, I think. That was compounded every minute. So let's look at what happens if we compound it continuously. So the future value is equal to the principal times the E to the rate 0.06 times the time, 8. So all of that's in your exponent. You've got to use that button that looks like that on there and keep that in your, all in your exponents multiplied together. What do we get? You just use the E button, yep. And it automatically puts that X thing up there. Yeah, so we did this last, I was just gonna do it here.
So on the board, there's a question on 6.0. I'll try every single formula and it still says it's wrong. So I'll pull it up. Okay, okay.
Everybody got $646.43. So we should have gotten. So it made a difference in the minute, but I think some of you even rounded this one to 43 cents here. The effect of that continuous was so far down in the decimal places that the dollar amount came out to be the same. So that's why we don't bother with compounding per minute. It does make a difference if you look at those values for monthly, it was 644.13, I think, or that was quarterly, 644.13. So it did make a little bit of a difference, compounding monthly versus continuously. And if it's over a long period of time, that continuous will make a difference between minute because it's still a little bit more money that's making money for you. Does anybody need me to look at what you put in the calculator before I move on? Did everybody get that answer? Anybody need me to see anything? Okay, so let's look at the top of the next page, these boxes up here. I kind of just put that problem right there. How much must be invested in an account earning 4% to be worth $10,000 in 12 years if it's compounded quarterly? So in the first box, we're going to do quarterly. In the second box, we're going to do continuously. So we're going to need both of these two formulas here, okay? Because we see compounded, we see quarterly, that tells us this one. We see compounded continuously, that means we're going to use this formula, okay? So we've got our variables that we need to fill in, our principal, our rate, our time, and M. Okay, so those are all possible things that we might need for our formula. So what do we know here? How much must be invested in an account earning 4% to be worth $10,000 in 12 years? What are we looking for? We're looking for the principal. So we know that the future value is 10,000. Okay. Our principal. What is principal? P, that's what we're looking for. What is our rate?
Rate?
Interest rate.
4%.
And written as a decimal, that would be 0.04. Our time,
12 years.
12 years. And our M, quarterly, so 4. Okay, let's fill in what we know. Future value is equal to principal times 1 plus R divided by M to the M times T. Okay, so future value, 10,000 is equal to P times 1 plus 0.04 divided by 4 to the 4 times 12. When you look at that problem, what do you think you want to do first? What is it? What's your intuition tell you? Well, multiply the 4 and the 12. Okay, so we'll do that. 10,000 is equal to P times 1 plus 0.04 over 4 to the 48. Okay? Yes.
Would the 4 not be 1 year 4 in the exponent?
For, the exponent is your M, so that's the quarterly, that's not your R. Yeah. Okay, now what's your intuition tell you should do? Because there's a couple of different ways you could work the problem. So what would you think you might want to do next? Do what's inside the parentheses, okay? Do what's inside the parentheses for me. Tell me what you get. $1.01, okay. Bless you.
How do I get rid of the fraction again?
Enter, shift equals. Okay, what next? Okay, I would, when you say divide the P out, what does that mean to you?
Put it under the 10,000.
What do we want to get by itself? The P, so we don't want to put it under the 10,000, because then it'll be over there with the 10,000. What do I want to get rid of?
Could you not move this 10,000 after? Or is that just too much work?
Well, then the P will be in the denominator, so then we'd have 1 over P. Let me just show you what would happen if I do. Don't write this word down. So if I divided by the 10,000, P is equal to 1.01 to the 48. All right, so now I'm gonna get rid of the 10,000. The 10,000 is in the numerator, so to get rid of it, we have to put it in the denominator, right?
Right.
So what would be left in the numerator here if I got rid of the 10,000? A 1, so I'd have 1 over P, because this is a common mistake students make. They want to just leave it as P, is equal to 1.01 to the 48 over 10,000, because I got to put it in the denominator to get rid of it. Well, now I've got 1 over P, so how am I going to get P?
You multiply it under P on both sides.
Okay, so then I've got 1 is equal to 1.01 to the 48 over 10,000 times P. Then what do I do?
You solve and then divide it.
Divided by this, and divided by a fraction is actually multiplication by the, what's that R word? Reciprocal, right? So I'd write the reciprocal over here, which is 10,000 divided by 1.01 to the 48 is equal to P. Okay, now, that would work, because everything I did there was correct. I think you might get lost in this last step. I also, where I see people get lost is right here with this 1 over P, because they just want to say, oh, there's only a P left, but they forget there's a numerator there. Okay, so let's go back over here. Yes.
So we're not doing that one.
No, I was trying to walk her through what she was, where her brain was going, so that she could see how that's going to come back around to something easier to do here. So what else could we do here? If we want to get the P by itself, you want to do the math here? You want to take 1.01 to the 48th power? Okay, do that. 1.01 to the 48th power. 1.65, 1.61, okay. Okay, now what? Divide by 1.61. Now, Harper, I want you to notice that 1.61 is just this 1.01 to the 48. So we got back to where you went, but we got back to it a lot faster. And what is 10,000 divided by 1.61? Over there?
No, on the one that you're under. Like, why did you do P?
Oh, because I'm used to seeing a number and then a variable. Yeah, you could have P times 1.61. That's the same thing. Order of multiplication doesn't matter. Addition, subtraction, it does, but 2 times 3 is equal to 3 times 6. So I can move stuff around when I multiply.
6 to 11. Yeah, me too.
6.
6,211.18.
Okay, let's see, maybe that 1.01 to the 48, 1.01. Oh, okay, yeah, so this number got rounded a lot. This is really 22607.8. If you do the whole decimal. So I'm gonna show you one other thing that you can do that's might be a little bit faster than simplifying all this stuff in here. Okay, when I get to right here, I would just do 10,000 divided by 1 plus my fraction button 0.04 divided by 4 to the 48. I wouldn't bother simplifying all that out so much because you've got a fraction button, you got an exponent button on your calculator. Let your calculator just do it, and then that keeps this rounding difference. Because you're right, this, if you put it in your calculator, what was the decimal here? 1.8. It is very different money wise. You know, if you owe somebody money, you'd rather not give them the extra $9, right? It is different when you don't carry those decimal places out here. If you did it this way, do you see you're getting that number? Yeah. So what that means to you is if you're going to do stuff like this, I need to know what you did. Don't just put an answer on your paper, because if you did this way and you rounded this to 1.61 and you didn't show me that you did that, I would have no idea where this $11 came from. I'd give you, some credit over here for whatever you did show, but if you showed all this, I'd give you full credit for that because that's just a rounding difference, okay? You knew how to do the problem. You just rounded something in there. So you got to show me the steps. I think it's more exact if you just go ahead at this point and divide by that. I wanted you to see, though, when we did this problem, that you kind of already know how to do this problem. And we might get there different ways, some of us even longer ways, but we all get to the same place at the end, okay? But it's really important that I see how you got to your answer because we can get different answers. Questions? Okay, do y'all prefer this way? Yeah, start just doing it that way. Anybody prefer this way? Yeah.
When I plugged that in, I didn't get that answer.
When you plug this in with all those decimals,
The grade.
when you plug that in, what? So you only have the 0.04 to the 48, you gotta use the parentheses, because it's all of that to the 48. Anybody else? You gotta use the parentheses if you're using that faster way. All right, now, the next part of this question said, what would the principal be if we compounded it continuously? So now we're going to use this formula right here. Okay, everything else from that column is going to be the same. Right, so we have future value in the box to the right is equal to P times E to the R P power. Okay, again, we don't know what the principal is. So we've got future value, 10,000 is equal to the principal, what we're looking for, times E to the 0.04 times 12. Now that exponent is the 0.04 in this one. Okay? So if you want to do it quickly, we know we want to get this P by itself, right? So we could just divide by all this. Make sure the 0.04 and the 12 are both in the exponent box. Use your fraction button, and what do you get? Just putting it in your calculator. See where the E button is? There you go. Right, your calculator?
It's not.
Huh, it's you.
If you need help using it. Different. You do? It's not.
These are the guys.
Yeah. Instead of my. I was thinking in the morning. Yeah.
Anybody have a question? Put that into your calculator. Yes, no, maybe. No? Y'all are talking to me today. Talk to each other. Anybody have questions? No to that or no? No. Hearing none. Moving on. How long will it take 3,000 to grow to 4,000? Okay, so this time we're looking for T. All right.
That's, never mind.
6187.83. So write out what we know and label it. And we're comparing again a compounded monthly and a compounded continuously. The only variable I will not ask you to solve for is M. I won't ever ask you to solve for M, but any other variable is fair game, okay? So on this one, we have a future value of 4,000, a principal of 3,000, an interest rate of 0.06, an M of 12, and a T of T.
Wait, oh, competitive monthly.
Monthly is 12. Huh?
I just got confused because I saw annual interest.
Oh yeah, that's why I tell you to look for the word compound and then look for the word that describes it, because it's interest is always yearly, right? But it's how many times they compound it in that year. Okay, so we've got the first one, future value is equal to principal times 1 plus the rate divided by M to the M times T. Okay, so fill in what we know. 4,000 is equal to 3,000 times 1 plus 0.06 to divided by 12 to the 12 T. Okay, so where is the variable? It's in the exponent. So what are we going to have to use if the variable is in the exponent? We're going to have to use logs. Okay, but not yet, because we have to isolate the exponential. This piece right here is the exponential. On the last test, I said it over and over again. What is the 3,000 doing with this guy? Multiplication. How do we get rid of multiplication? And yet y'all subtracted. Okay, divide by 3,000. I'm just going to leave that as a fraction because it is a repeated decimal. So I'm just going to reduce it to 4/3 and leave it as a fraction. If it gave me a decimal that terminated, I would use the whole decimal. But since it's a decimal that repeats, I know how fast the answers can change, so I'm gonna leave it in the fraction. So I've got 4/3 is equal to 1 plus 0.06 divided by 12 to the 12 times t. Okay, what should we do next? What would the exponent?
No.
I can't multiply 12 with t and get anything different. Try again. Parentheses, do what's in the parentheses, simplify that. I've got 1.005. Let me just- that's right. Now, the other thing that y'all did at this point was just to forget about the fact that the test was on logs and divide by this. This is not this times this. This is this to this power. So I have to use logs. What base log would I use in order to make it the problem easiest? Yeah, 1.005. So log base.
Thought we were done with one.
No, 1.005 of 4/3 is equal to log of 1.005 times, sorry, I'm running out of space, 1.005 to the 12t. Okay, so I've got this log base and the base match, so what happens to them?
They cancel.
They cancel,
Like this.
which means this 12t can come down in front. And then how do I get the t? Yeah,
Where's that? 1.005, is that right next to the log? Or is it?
this one,
No, the next one. Yes,
this one.
yes.
So-
That's the base, 1.005, that's the base.
Yes, and then
that's, okay, thank you.
does that help? See it like that?
Yeah.
Okay. Bless you.
And then you just cancel those out because they're, okay.
The base and the argument match. And then what do we do to get the t by itself? Divide by 12. Put it in your calculator. Yeah, 4.80, is it 6 or 7?
667.
All right, 7, and it's always in years. Anybody need me to look at a calculator? Anybody need another second?
Do you think that if I put 1.3, it will give me a different number?
Yeah, it would.
Okay, so I need to keep it a fraction.
Or do 1.33333333 and put a bunch of them.
Oh, yeah, that should be that.
Okay. Let me give everybody a second to practice putting it in, then we'll move on to the continuous. Four point eight oh seven,
Oh. I got 4.9.
that's fine. Alright, good. Alright, so now we want to do the same problem, but we want to figure it out continuously. So this one, we're going to use future value is equal to principal times e to the r times t. Again, we're looking for t, so we're going to have to use some type of log. It's got an e, so I'm guessing it's going to be natural log. So I've got 4,000 is equal to 3,000 times e to the, what's my rate? 0.06 times t. Okay, start off the same. Isolate the exponential. The exponential is the e to that power. So we're going to divide both sides again by that 3,000. Four thirds is equal to e to the 0.06 t. Okay, I've isolated the exponential. The variable is an exponent, so I have to use logs. What log base? The natural log, because the natural log is log base e. I'm going to take the natural log of both sides. Okay, LNE is 1. So that cancels out. My 0.06 can come down in front. Get the t by itself. Divide by 0.06. T is equal to. Do you still do your natural log of both sides, or are you using the change of base? I know on this one you have to do the natural log, but over here, did you do log base 1 point, or do you divide? Do you just do the natural log the whole time? Yeah. What'd you get? Yeah. Anybody need help? Of course. So when you're basing your argument, it's mapped into 1. And then this is your power to power, so you change it to multiplication. So it'll be 12p times 1. Yes. Yes, that gets crossed out. Anybody? All right, try the next two. Work with somebody. What annual interest rate? So this time you're solving for the rate. So we're solving for this R here, or we're solving for this R in the exponent. So this one, you don't have to use logs because the R is not part of the exponent. This one, you're going to have to use logs because the R is part of the exponent. Okay? You have to use something a little different for this one. So go ahead and try those two, see where you get. Label what they gave you, all this stuff, start with that. So the first one is compounded semi-annually. What's M if it's semi-annually? 2.
So we can have to know those. I think I already asked that. We have to memorize those. but not
They
the
should be,
formulas.
but not the formulas. I mean, they should be pretty much.
Yeah, I was just wondering.
I mean, if you don't know how many weeks there are in a year, I'll tell you it's 52 on the test, but. No, it's the board. Anybody still copying anything?
wanna do this six numbers, so that way. That looks good, so that was better. This, not even a cube, this, yes, so make that a six.
You gotta divide by the 900. For 27,000.
Leave it as a fraction 10/9 because that's gonna be a feeding. Alright, and now you're still stuck in the same place. So that's to the sixth power, what's the opposite of taking something to the power? The root of it, right? So not the square root, but the sixth root. Right, and that, what you do this for. You do, yes. Was it? We can't do that yet, because order of operations says we have to use, right, we can't do what's in the parentheses, because there's a parallel there. But, so we can do this exponent, and that's the sixth root, sixth power. What's the inverse of the sixth power? For the sixth root. So you're gonna use this funky little button right there that allows you to pick any root you want to go in. Yeah, just shift. Oh, you did. You mix these up. This is your principal, this is your future value. So you can do that, you're changing.
Yes. I'm still. Yeah.
Yeah, but I just left it as city, like, I just left it as in the. Wow, that's good, like that, right? Is this right? Oh, but I don't want to do it. Easier to say, well, so R equals 4%, right? So to leave it like you had it, okay? It's easier to look at full like this, and then.
What does that equal 1%? It's
And then-
0.04, but 5/2.
Yeah, I got.
Yeah, you do.
I got very, I didn't realize.
It's
divide by two.
It's divided by two, so you get rid of some of the R.
It's probably because I did.
No, that's crazy.
Yeah, I. So on the test, if I'm not close, are we getting kind of that's right? Not that's weird. Yes, so I got. But I didn't.
You guys do that. Like to write it down.
Otherwise, you would have, and with the sixth root.
Of course.
Yeah, ready to help you with the first one?
Things you don't have.
No.
Not yet?
You get the sixth group on the 10 minutes.
You do, both sides.
I did not push throughout out.
Be careful using these rounded decimals, it is giving us very different answers.
Now, this
So
is
wait, you listed power, so that.
I got it.
Wait, so.
So that's one question.
If you could use that, or they are. And then multiply it by seven.
Yeah. No, yeah, 56.
Oh, I see how you did it. Okay, that makes sense. You
Then you subtract the.
So you just entered it into this section.
Exactly. I wanted to left.
Okay. So you see how it's all about my space? There we go, my space. Let's get rid of this. So
whatever you did was right.
Guys, you gotta carry these out enough decimal places that you see the difference, okay? Because they should be different interest rates if one's being compounded monthly and one's being compounded continuously. We want to be able to see where that difference is, okay? So 1,000 equals 900 times 1 plus R over 2 to the 2 times 3. Okay, so we divide by 900, that gives me 10/9 if I divide by the 900 and I reduce it. Is equal to 1 plus R over 2, still in the parentheses, to the 6th power. Okay, so when we take to undo the 6th power, the inverse of that is the 6th root. So you should be able to find that button on your calculator. If you can't, let me know. We have to fill in the 6. 6th root of 10/9 is equal to this. If I take the 6th root of this side, it just drops out, R over 2. Okay? So then to get the R by itself, we're going to subtract 1. And I did all this. I just kind of left this on mine. Equals R over 2. Some of you I saw change that to a decimal. It was a long decimal, I think, that kept going. So you really got to give me enough decimal places. Try to go with 4, and then hopefully you'll see what happens there.
It was still the same.
It still was the same answer. Okay, I did mine leave it like that. Now, something else I saw on the test that I thought was so odd at this point. When you had R divided by 2 on the test, some of you divided by 2 to get rid of this 2. If this 2 is dividing, how do we get rid of it? Multiply, okay? Pay attention to that. And so all this gets multiplied by 2. I got putting it like that into my calculator. R is equal to 3.54. Now, some of you I saw rounded and you got 0.04. And this was like, I guess, 0.0354, but I wanted to change it to a percent to put that label on it.
So if we keep it as the, I don't want anything to count that wrong.
Well, when I ask you a word problem, I want you to label it. So I would want you to change it to a percent so that you can give me the percentage rate of interest that you're earning.
So do you want like 4 decimal points then?
I did on this one because I wanted to see the difference. On a test, I'm going to be following your work, but give me, yeah, just kind of make it a habit, do 4 decimal places. That's what I say in my statistics class too. It gives you enough decimal places usually to see the difference. Okay. Now we look at this one, this continuous one. So we have 1,000 is equal to 900. E, we're looking for the rate times the time is 3. Again, I like seeing the number in front of the variable. So if I'm writing it, I would write 3R. So I've got 10/9 because I divided by the 900 is equal to E to the 3R. Now my variable is in the exponent. So what do I need to use? The natural log. ln E is 1. 3R gets to come down as a cut. So 3R is equal to ln of 10 divided by 9. The 3 is multiplying by the R. So to get rid of it, we divide. And I got R is equal to 0.0351, which is 3.51%. So that shows the difference in those interest rates by having that 4 decimal places. I did, because it was 3 times R, so I divided by 3 to get the R by itself. All right, try the last 2 problems. You're looking for future value. You're looking for future value compounded semi-annually, and then I wanna know what the interest is, not the interest rate, the interest dollar amount that you earned. Okay, show me that and you can leave.
Where's interest?
Interest is future value minus principal. Raise your hand when you're ready, if you got it.
No, check it and you can go. That's. Yes, you may. You may. Those last two, the rate you need.
These are residents.
Just looking for the future value, so it should be really quick.
Right.
Got 2 minutes, and then I have to let you go.
Got it.
Then I'm gonna turn this off.